All right, let's talk about something that drives every machinist crazy. You've got your Okuma LOC 650, a real beast of a machine, but then you see it. The turret takes the long way round, just bleeding away cycle time. Today, we're going to cut through the noise and give you a simple, systematic way to diagnose and fix this thing for good. Let's jump right in.
So you know exactly what I'm talking about, right? You command a tool change from station 1 to 2, and instead of a quick little hop, it decides to go on a grand tour all the way around. That's the scenic route, and yet every single second it's sightseeing, you're losing money. And when you look at the guts of this thing, you can see why it's so fast. When it's working, this isn't just some simple motor. It's a pretty sophisticated hydraulic system, and it's built for one thing: speed. But if just one little link in that chain breaks, all that beautiful efficiency just goes right out the window. Don't worry though, we've got the roadmap to find exactly what's wrong. Okay, so first things first, let's be crystal clear about what we're actually trying to fix. The whole problem centers around a function called short path control. We need to get what it's supposed to be doing before we can figure out why it's, not doing it. The idea behind it is actually pretty brilliant. Every time you call up a tool, the control does this super quick calculation. Is it faster to go clockwise or counterclockwise? It picks the winner and sends the turret on its way. It's all about shaving those precious seconds off your cycle time.
All right, let's get our hands dirty bit, metaphorically anyway. Our first step is the easiest one, and trust me, you always start here. Before you even think about grabbing a multimeter or a wrench, we're going to check the software. Because a lot of the time, the fix is literally just a single mouse click.
And here it is, the machine user parameter screen on that OSP control. This page is ground zero for our entire investigation. Believe it or not, one little unchecked box right here could be the entire source of your headache. So here's the deal. It's super simple. If your upper A turret is the one acting up, you need to make sure that first box, turret short path control A side, is checked. If it's the lower B turret, you're looking at the second one. If that box is empty, the control isn't even trying to find the short path. Check the box, and you might have just fixed your problem in under 10 seconds.
But what if the parameter is checked and it's still taking the long way home? Well, that tells us something important. It means the brain is working, the logic is turned on, but the message isn't getting to the muscles. So now we've got to follow that signal from the software all the way out to the hardware. Okay, let's meet our main suspects. These 4 solenoid valve coils are the guys that actually tell the turret which way to turn. You've got YV65 and 66 for the upper turrets forward and reverse, and YV70 and 71 for the lower turret. The CNC sends out a command through a very specific wire to wake one of these coils up. And this is our treasure map. I know, electrical schematics can look like a plate of spaghetti, but they tell a really simple story. You can literally trace the line from the CNC output, like OTCW here for the B turret's forward command, and see it go straight to its coil, YV70. Our job is just to make sure that electrical signal is actually making the trip. So, that's our mission. We're going to grab a multimeter, and we need to prove that when the machine commands a short path move, a 24-volt DC signal pops up right where it's supposed to. So if the B turret should be going forward, we better see 24 volts on wire number 196D3, simple as that. Okay, now for the most important test in this entire process. Let's say you've confirmed it. You're getting 24 volts right at the coil, but the turret still isn't going the right way. This next test is what I call the Great Divider. It's a simple hardware test that will tell us with 100% certainty if we have an electrical problem or a mechanical one. We're going to do 3 really quick things right there at the valve itself. First, just use your ears. When a command is sent, can you hear that little click of the solenoid firing? Second, with the hydraulic power on, find the little manual override button on the valve and push it. And third, with all the power completely off, check the coil's resistance. But honestly, out of those 3, this is the one that really matters. This is the million-dollar question. When you physically pushed that little manual override button on the valve, did the turret move? Your answer, a simple yes or no, tells you exactly where to look next. And here are the 2 paths. It's that simple. If you pressed the button and the turret moved, congratulations, the hydraulics and mechanics are fine. Your problem is definitely electrical. The signal is there, but the coil isn't doing its job. But if you push that button and nothing happened, you can forget about the wiring. The problem is deeper. It's either hydraulic or something is physically jammed.
So now we're in the home stretch. That override test was our fork in the road, and it pointed us down one of two paths. Now, all we have to do is walk down that path, either the electrical one or the mechanical one, and find the final culprit.
Okay, so if the test told you it's an electrical problem, your focus is squarely on that solenoid coil. With the power off, check its resistance. If you get a reading that's way up at infinity, that's an open circuit. If it's close to zero, it's a short. Either way, the coil's toast. Also, give the connector a good look. Sometimes it's just a cruddy connection. And remember, a coil can get weak over time, where it has resistance but just doesn't have the oomph to actually shift the valve. Now, on the flip side, if the override test sent you down the hydraulic and mechanical path, you've got a whole different checklist. Start with the easy stuff. Is your main hydraulic pressure where it should be? Then check the speed control valves for that turret direction. Maybe they're clogged or someone closed them. It's also possible the valve spool itself is just physically stuck in the bore, or you've got a much bigger problem, like a mechanical bind in the turret itself.
So let's just boil this whole thing down. It's a simple 4-step game plan. 1. Verify the software parameter. Easiest thing first. 2. Trace the 24-volt signal to the coil. Follow the money. 3. Perform the manual override test. This is the great divider. And 4. Isolate the final fault, whether it's electrical or mechanical. That's it.
You know, when you really think about it, it all comes down to this. That shortest path is only as reliable as the weakest link in a pretty long chain. From a single checkmark in a piece of software to a tiny spool inside a hydraulic valve, everything has to work perfectly. It kind of makes you wonder, what's the simplest function in your shop that's secretly way more complex than anyone thinks? Something to chew on.